Today I'm going to revisit something that I did about a year ago, which was to convert the batteries in this Uniden scanner from their old NiCads to lithium ion. At the time, I was just using pieces and parts that I had lying around. I have since ordered some other bits and pieces, so hopefully I should be able to do a little bit better job of this. Not that it isn't working. It still does accept the charge from its original 12-volt charger using its original connector. However, because of how I did it then, I find that this thing does self-discharge when I'm not using it for too long. That was because of a basic limitation of what I had to work with at the time. So let me just open this guy up, if I can remember how. Yeah, there we go. If you want to know more, you can go back and take a look at the video. I'll put a link to it up in this corner up here. Anyway, I used a salvaged vape cell because, they're free. And I used a little charge, no, what is that? That is the original charge connection and its original LED. I've got a battery charge module down here, and I have a buck converter, I believe, to knock the voltage down from the 12 volts coming in to what the charge module can deal with. And if I remember correctly, I also have a boost converter so that we can get 6 volts out of the battery. Yeah. So that is down underneath this little sandwich of boards here as well. The comments at the time suggested that I should use a 2S instead of just a single cell to eliminate any switching noise from the boost converter. I'm not really experiencing too much switching noise, but I am finding that the boost converter, even when it's sitting there idling with no load, does draw some power and draws the battery down eventually, which is less than ideal. Although I did put a battery protection module on there to protect from over discharge, so it's not harming the battery any. It just doesn't stay charged for as long as I would like it to between uses. So what I'm going to do is remove all this stuff. I'll leave the original factory board in there as my interface, and I will install a BMS for 2S LiPo. I will put 2 batteries in here instead of the single one. And then I will put a 2S capable charger in. I have a few different ones to choose from, and hopefully this stuff will all fit in here, but that is my plan. Oh, good. The air conditioner stopped. Sorry about the noise in the background. It's just stupid hot outside again, so the air conditioner will be kicking in and out during this video a few times. And then if I remember correctly, yes, I did use some VHB tape to stick that in there. It held pretty well, so that is good. I'm going to guess that that's probably what I put underneath here as well. Seems like it, yes. That is very tenacious tape, and I may end up using it again. Let's start disconnecting things here. First, the battery, just so that this is safe to play with. Eek, eek, eek. Don't be shorting that out, that would be bad. Now then, my stack of boards here. There's the 2 wires that go out to the radio, and then just the wires coming in from the charge here. And I'm hoping that the black is the negative. I'm hoping that I actually did a little bit of color coding on this thing. Usually I don't do too much color coding because of my color blindness, but black should be predictably ground or negative, I would think. Come on. So there are the 2 original boards. That is a buck for the incoming, and that was a charge control and boost output. I'm going to put those back into stock just because there's no reason to throw them away. And now let's choose from our boards here. So I have various different series versions here, but I will grab a 2S because, of course, this is going to be a 2S pack. I probably should have ordered some that are a little bit lower current. This is going to be way overkill, but on the other hand, it's way overkill and it's not going to hurt anything. The control chips on here, we have an FM702A. Well, searching for the FM702A was a little bit elusive, but I did come up with this web page, obviously in Chinese. I couldn't get a full translation of it, but I got the basic text out. It is a battery protection IC, as you would expect in something like this, and it is suitable for 2 in-series connected lithium-ion or lithium polymer rechargeable batteries, which is exactly what we're doing here. Then there are 2 of these BB3A, one for each cell, and they're associated with an A2SHB. The A2SHB is a MOSFET. That's a very common one. Another one that it took a little bit of detective work to get to, but that BB3A translates into also an HY2213, which is a lithium-ion polymer battery balancing IC. And there are some samples of how to use it. Just put 1 per cell in your stack of cells, however many you have in series. And there is a dump resistor here and a transistor, a MOSFET, that it will kick in if your cell gets out of whack with the other ones. If it gets overcharged, and it'll bring it back down again to be in balance with everything else. So again, there's that protection chip, and if there's an overvoltage or overcurrent, it will open up these MOSFETs and disconnect the load from the cells. And there are the 2 balancing chips with their MOSFETs and their dump resistors should they sense the 2 cells getting out of balance. So that should do the job for us for managing our 2 cells. And then for my various chargers here, I think, yeah, there's the one that I found. This charger is based on the TP5100, and it is capable of doing either 1S or 2S, and you can adjust the charging current as well. There are data sheets, but even better, I found this blog article that explains that it can charge up to 2 amps. We're not going to want that. It can either do 1S or 2S, 8.4 or 4.2 volts. There is the exact module that we've got. When you're in 2S mode, as we're going to be, you just short those 2 pads there. And the only other thing we have to look at is the sense resistor, which is that guy there, and adjust it so that we don't boil these batteries, because I really don't want to charge at 2 amps. So looking at this chart, I want somewhere between 1 ohm and 0.2 ohms probably. That sense resistor is actually these 2 resistors in parallel. Right now it's 2 1 ohm resistors in parallel for half an ohm. I think I want to pull one of those out of there so it's only 1 resistor for 1 ohm, which hopefully I can do without too much fuss. We'll have to see. Sometimes these surface mount components don't want to play nice. There we go. And to figure out what's going to fit, I'm going to have to dig through my collection of salvaged vape batteries and other batteries and find out what's going to both mechanically fit and also pick 2 that are the same capacity as well, as you don't really want to build a battery pack out of cells that are not matched very well. So let me just dig through these and I'll get back to you in a second. There, I think I'm going to settle on these. That's a pair of 560 milliamp hour cells. I could go a little bit larger with these ones, but I don't think I could get both of them to fit in there and my 2 boards. So that's what I'm going to go with. So the first thing I think I'll do is hook up the input 12 volts to the between 5 and 15 volt input on this thing. And then the output of it will go over to the plus and minus of the balance board. Oh yeah, and before I forget, I have to put the little jumper in there to set this into a 2S mode. That was easy. Here's the negative and the positive input. I think that'll sit just down there nicely out of the way. I do want to make sure before I close it in that that will fit under the cover. I'm pretty sure it will, but I just want to double check. Well, maybe not. I might have to okay, a bit more fiddling around, and I think that that is actually the orientation that I have to put it in. I would have liked to have had this board up on edge, but it won't fit under the cover. So I think this will still work though, and it will still give me a little bit of space around everything. Although these two 43 ohm resistors, those are the ones that dump the current from these cells when it's trying to balance them. So maybe I'm going to want to have that guy facing the other way, just so that the heat is further away from the cells. Like that, yeah. I think that is how I want it to be, which means the common between the two cells is over here. So those two wires get tied together, and then the 0 volts is the lowest voltage that'll go there, and the 8.4 is the highest volts, which will come off that one. And then I'll connect this to the output of the BMS, and I'll connect the charge to the BMS, which is both the input and the output, I guess, really. And then we should be done. And there is the midpoint between the two cells. And the 0 volt goes to there. And the most positive ends up here on the 8.4 volt terminal. And if I did that correctly, I should have about 8 volts there. 8.2, that's exactly what I want. Which means that I should have very close to 4 volts on each of my batteries. 4.1 there and 4.08 there. Close enough to in balance. When I charge it, that should bring them back into balance with a little balance controller there. Now then, I have to secure all this stuff in here, and I think I will just return to exactly what I did before and use VHB tape. But I also want to put a little bit of Kapton around the ends of these cells just to make sure that they don't cause any problems. I probably should have done that before I soldered everything up, but well, I'm doing it now. Again, this VHB stands for very high bond. It is a very strong and aggressive tape. Well, you saw how hard it was for me to pull it out from the previous installation. So I don't think it's going to cause any problems here whatsoever. And that should be the last bit to jam down in there. Everything is fairly well secured. And then just get all the wires kind of managed. Oh, that's going to be a problem. May have to rearrange things in here a little bit after all. I didn't think about where that was going to land. Let me just mess around with this a little bit more, and I will get back to you again. Yeah, that is completely clearing the batteries now. I am happy. So that just snaps back together. Sorry about the loud noises. The charger still charges. That's good. We still have our 8 volts on the output. That is good. Now then, the original battery was a 6 volt battery, but when it was charging, when it was plugged in its original configuration, it would put out 12 volts. out the port while it was charging. So I am not concerned at all that that 8 volts is going to be too much for the radio. And there we are. It is scanning. And it is even able to pick up local radio stations, no problems. I'm down in the basement, so I am not going to get any two-way radio stuff at all. There's a lot of interference and a lot of noise down here. But it was working before with no problems, and it wasn't causing me any interference. And now, because we're going straight off the batteries into the unit itself, it should be even cleaner than it was. But again, like I said, I wasn't hearing any audio interference off the other batteries with the little boost module either. So I think that is a successful transplant. Hopefully there will be a lot less leakage, well, not leakage, but drawdown, because we don't have that boost converter on there anymore. And with the charging module that is set to a lower current, we shouldn't cook the batteries. I think that's a win. Well, thanks for watching, everybody. I do appreciate it. Once again, if you want to see the original modification that I made and what this thing looked like factory, I'll put a link to it. Well, I put a link in the corner earlier. I'll put a link down below as well to that earlier video. But anyway, yeah, I think my accumulation of parts, my ongoing accumulation of parts and ever-growing accumulation of parts has come through for me. What do you think? Questions or comments down below? I'll talk to you later. And because I know somebody's going to ask, the beer today was Another Deadly Sin from Bookstore Brewing in Winnipeg. It's a nice malty low hop English ale. Very nice on these hot summer days.